So hopefully in question number 1, you made that link between the expression that we were working on and the table or sequence values that the expression directly tells us, because we're going to use that same idea in question number 2. Question number 2 gives us a specific expression that looks a lot like the one from number 1, but with a clear difference. In number 1, we had the initial value and the multiplier with a power of x. And in question number 2, we still seem to have something that appears to resemble an initial value. We still have something that appears to resemble a multiplier, just based on where those things are located. For example, I can always recognize an initial value because it's outside of the parentheses, not attached to the exponent. I can always recognize a multiplier because it is inside the parentheses. It is directly attached to the exponent. But this time, the exponent is not a variable. This time the exponent is a legitimate value, -2. So hopefully, based on what you saw in the previous example, we realized that the exponent was just telling us which term number we were referring to in a sequence. So for example, in number 1, letter C, when we said if x equals -3, we were really talking about 8 times 1/4 to the power of -3. But that's actually just saying, hey, go to the table, go to the -3rd term. So it's telling you where in the top row of the table to look for the value of the sequence in that spot. So now that I'm looking at this expression in question number 2, I'm seeing it as a table of values, a sequence, if you will, with an initial value of 20 and a multiplier of 1/2. So if I set up a table similar to the one that I made for question number 1, I would say to myself, okay, the initial value appears to be the 20, just based on its placement, and we know the initial value is always the 0 term. The multiplier always takes us to the next term to the right, or the next term of x. So if x is 0, the next term would be x 1, and the multiplier tells us that to get there we need to multiply by 1/2, which could also be thought of as dividing by 2, whichever way works better for you. Half of 20 is 10. Or 20 divided by 2 is 10. And that tells us that to get to the next pattern, or it's the next term in the pattern, we divide by 2 again. And we would keep dividing by 2. Or, again, if it suits you, multiplying by 1/2. It works the same. But this is taking me in a direction I don't need to go. Because remember what we said at the beginning? It's not really asking us about an infinite number of x's. It's actually just asking us about a specific x. The x at the x coordinate -2. So if I think about my table, -2 would be backwards a little bit. I would have to go from my 20, which I do know for sure, that the 0 term is established for us, but I'd have to go backwards through the table. So if we think about it logically, going backwards through the table means we're doing the opposite of the pattern. So if the pattern was dividing by 2 to go forwards through the table, backwards through the table must be the opposite, multiplying by 2. So the -1st term backwards must have been 40, because 40 divided by 2 would have been 20, divided by 2 would have been 10, so the pattern would have worked. And then going backwards one more time would have been 80, because 80 divided by 2 is 40, divided by 2 is 20, divided by 2 is 10, the pattern would have worked again. So the idea that I've gone backwards to the -2nd term is probably not that shocking, but the fact that this was telling me to focus on something specific, like, hey, go to one specific spot in the table and use the pattern to get there, that's what this question is driving at. So if you can, try to kind of chew on this idea for a second, that this expression was telling you to go to a specific term in the sequence, and just try to make sure that you understand the logic between how we got there and why we got there. So to answer each question, I'm not going to walk you through necessarily, but I think these effectively summarize the work that I just did. If you knew where the initial value was, how did you know? What was the initial value? What was the multiplier? What was the value of the -2nd term? And if you can articulate, how did you know in the table where the -2nd term was? How does this expression directly tell you that? If you can think about it mathematically, another way to look at letter C is to ask yourself, well, how would you have gotten 80? Does this make sense that this answer, 20 times 1/2 to the power of -2, is 80? How would that answer have come about? Did I have to make a table to get there? Could there have been another way? I mean, obviously you can type it into a calculator, and that's not what I'm referring to. Is there some math that you could be thinking about, some manipulation you could do to somehow turn this into the number 80 so that you didn't have to do a whole table? That's what question letter C is asking you to think about. And there's no right answer to that yet. It's just food for thought. I'm going to give you a few minutes, of course, to think and chew on that idea so that you don't rush right into the next video without making sure that you can kind of see this connection. Our ultimate goal is to get ourselves to the point where we could look at any expression that looks like a geometric sequence and to know three things right off the bat. What is its initial value? What is its multiplier? And which specific term do they want me to know? That way I can efficiently set up a table and go straight to the term that I know without having to calculate a whole bunch of other terms that I didn't need. Because notice all this work I didn't need. I didn't need to go to the third term. I got a bit carried away with myself. I didn't even think about the fact that the third term was in the wrong direction. So now we want to try to be a bit more purposeful. If we're doing a sequence problem, how do we know which direction to go to right off the bat so that we can start with what they gave us and immediately move in the direction that they want us to go to, in the part that they're asking us for, without wasting our time with a bunch of numbers we didn't need. So anyway, that's food for thought, just making sure we understand this concept before we get into the next video. In the next video, we'll talk about what this means in the context of real practice problems.